using deep features and recurrent network proposed by Duy-Tue, Tran-Van, Lê Vũ Trần, and Professor Minh-Triet from Ho Chi Minh University of Science. So during the time researching in the video memorability, the authors found some very interesting information that the video semantics works best on the predicting memorability, and the C3D is usually refers and uses visual features. And there was related work proposed by Cohen-Det, who used an LSTM with visual features for the long-term problems, but they state that the results were not promising due to small data sets, around 660 videos. However, in this task, we have a quite larger data sets with 8,000 videos. So the authors believes that the LSTM is a possible solutions for the long-term memorability. The author also tested the video caption with LSTM, but there's no significant improvement comparing to the CNN following by a fully connected layer. And the author also tried to use AMNet proposed by Fetchies, because there is a very interesting techniques in the AMNet, which is the attention approach, and also the AMNet has a very high, a very good performance on the LAM-M dataset. So that's why the authors they decided to try it. And here's the overview of their methods. They extract frames from videos and feed them forward through pre-trained CNN models, and then iteratively use them as inputs at the LSTM model, followed by a fully connected layer to get the final score, the memorability score. And this is the frame extraction step in detail. The author extract 8 frames for each of the videos, and they state that if they increase the number of frames in the extraction step, they might able to have an improvement in the result, but it will slow down the training process, so they decided to use only 8 frames. And after having the extracted frames, they feed them into an inception V3 pre-trained on the ImageNet to get the feature vectors. And after that, they use an many-to-one LSTM model with different number of hidden units, followed by a fully connected layer to combine the outputs of the LSTM model to get the final score. And this is the results for the short-term subtask. The author submitted 3 LSTM models with 3 different number of hidden units: 512, 1024, 2048. And they also submit to AMS model, one with attention and one with the attention. And the results show that the LSTM models has the best performance amongst 5 runs, their 5 submissions on the official test set. And for the long-term subtask, when the author experiment with their models, they found that surprisingly the model trained with short-term labels usually perform better than the model trained with long-term labels. So they decided to submit a model, the second one, which is trained with short-term labels but validated with long-term labels, and the results show that this method achieved the best result among the submissions on the official tests. These are some discussion from the authors. Natural scenes, backgrounds, and landscape tends to be less memorable, while people and objects are easy to remember. And the author also found some similar videos in the data set, but they have very far distance in their long-term labels, and this caused the confusions to their model in long-term memorability. So they may consider to apply some data filtering techniques to remove this outlier. And in the conclusions, the proposed method only focuses on temporal and visual features of videos, and semantics and other features will be considered to further improve the correlation score. Okay, yeah. Thank you for listening.